In this problem, we have to verify the transfer function of the circuit shown below is given V0 of S over Vs of S is equal to H of S. And what we'll do is we'll start off here. We're eventually going to have to get in here and express this in terms of this. And we'll approach this with nodal analysis. So here's our circuit. And what we'll do is I'm going to define this node voltage as V1. And we're going to write an equation for that. Now also, by the ideal op-amp model, this is a virtual ground. So there's also a reference at that node. Now let's do KCL at these two nodes. And again, what we're trying to do is we're trying to write V0 of S in terms of Vs of S. So let's start first at this node. We're going to sum currents leaving that node. So if we look, we'll have V1 minus Vs over R1. And then we'll have, here we'll have V1 over R3. This way we'll have C2S V1, and then this way we'll have C1S times V1 of S minus V0 of S. And that's all equal to 0. Now let's apply KCL at this node. Let's sum currents entering. So we got entering here and here. So we have C2S times V1 plus V0 of S over R2 equal to 0. So now from this equation we can express V1 in terms of V0, and we can use that to eliminate it from that equation. So if we look, we have C2S V1 of S is minus 1 over R2 V0 of S. So then V1 of S is minus 1 over R2 C2S times V0. So now we're going to take this and we're going to substitute it in up here. So let's take this first equation up here and let's first rearrange it. Okay, so the first thing we're going to do is we're going to rearrange this equation. Okay, so here we go. We'll collect up terms. So we'll have V1 of S. We'll have 1 over R1 plus 1 over R3 plus C2S plus C1S minus C1S V0 of S minus Vs of S over R1 is equal to 0. So now I'm going to go in now and make this substitution in here. So now we have V0 of S times minus 1 over R2 C2S times 1 over R1 plus 1 over R3 plus C2S plus C1S minus C1S V0 of S is equal to Vs of S over R1. So now it's a matter of some algebraic manipulation. So let's multiply this equation through by a negative sign, okay? And let's collect up terms here again. Let's simplify some. So this first term becomes 1 over R1, R2, C2S plus 1 over R2, R3, C2S. That's this term. This term becomes 1 over R2. This term becomes C1 over R2 C2. This becomes C1 of S. And then what we have is we have minus Vs of S over R1. So we multiplied through by minus 1, and I just multiplied through here so we can start some algebraic manipulation. Now let's multiply this equation through by S. So when we do that, we'll have 1 over R1, R2, C2 plus 1 over R2 R3 C2 plus S over R2 plus S C1 over R2 C2 plus C1 S squared is equal to minus S Vs of S over R1. Okay, so now let's divide this whole equation through by C1 to get that leading coefficient of the S squared term to 1. So when we do that, this will become V0 of S, and we'll have 1 over R1 R2 C1 C2 plus 1 over R2 R3 C1 C2 plus S over R2 C1 plus S over R2 C2 plus S squared, and that's equal to minus S Vs of S over C1 R1. So now let's work on this, rearranging this a little bit. So V0 of S becomes S squared plus, we have 1 over R2 C1 plus 1 over R2 C2 times S, and then we have 1 over R1 R2 C1 C2, and if we want to get this over a common denominator here, we could go in and write this as R1 over R3, and then this would be R1 R2 C1 C2 is equal to minus S Vs of S over C1 R1. So what we did here is we're left with a term here, and to make it have the same kind of common denominator, we just divided out, we just rearranged the math here to make it the same. So we multiplied through by R1 over R1 and pulled R3 in there. Okay, so now we're ready to solve from this. So now we have V0 of S over Vs of S. Okay, we have minus 1 over R1 C1 times S. And down here in the numerator we have S squared. We have 1 over R2 C1 plus 1 over R2 C2S, and then we get this last term, this 1 plus R1 over R3 over R1 R2 C1 C2, and again that's the way we manipulated. We took this term, moved R3 up into the numerator, and so we had the 1 over R2 R3 C1 C2, so we moved this up into the numerator. We had R2 C1 C2, and then what this just multiplied through by R1 over R1, so we had R1 over R3 over R1 R2 C1 C2, and that's how we're able to get it to this term here on the bottom right.